Good day, students. We will have the continuation concept of transmission lines with the heading of lossless and distortionless line. As the name indicates, lossless and distortionless, we will have the basic definition of transmission lines first. At once I say the term transmission lines, there are only two constants, primary constants and secondary constants. You choose a small section of transmission line which has the definitions of resistance, inductance, conductance and the capacitance. Here the definition is very clear. R dash is the resistance per unit length for the transmission line and the unit is ohms per meter. L dash is the inductance per unit length of the transmission line, henries per meter. Conductance per unit length is G dash, which is Siemens per meter or Mohs per meter. And C dash is the capacitance, which is defined in terms of farads per meter. So simple representation of the line element is transferred in terms of the RLCG constants. When I speak about secondary constants, the primary condition is characteristic impedance Z0. So Z0 has to be defined, which is independent of line length. So we cannot measure it using the multimeter. So we are choosing the distributed circuit parameters. Impedance is R plus J omega L. Admittance is G plus J omega C. So using the relation of Z0, characteristic impedance is denoted by Z0, which is equal to root of the definition of Z divided by Y, R plus J omega L divided by G plus J omega C. And then is the secondary constant, which is the propagation constant, which is measuring the changes in the sinusoidal electromagnetic wave in terms of both amplitude and phase when it is crossing through the medium. And this can be either a transmission line or it can be a free space transmission, and the propagation constant, as we know, is dimensionless. So we are denoting it by gamma, which is equal to alpha plus J beta, where alpha is the attenuation constant and beta is the phase constant. As we see in the mathematical equation, alpha is a real term and beta is a complex term. Alpha, it causes a signal amplitude to decrease while propagating through the transmission line, and it is really a positive number. And if we have a negative number, then the attenuation constant is violating the first law of thermodynamics. So the definition of this unit alpha is decibel per meter. Same way with respect to phase constant, it will give up the phase of the signal along the transmission line at some particular constant time, and the unit is generally radians per meter, and also some of the times we denote it as the analysis of degrees per meter. Now we will have the definition of distortionless and the lossless lines. The condition for distortionless line as per definition is RC must be equal to LG, which means that the attenuation constant should be purely independent of frequency. It is a product of resistance and the conductance. But the phase constant beta is omega root of LC, where omega is equal to 2 pi f. So alpha is independent of frequency, beta is dependent of frequency, whereas the velocity of propagation is independent of frequency, again 1 by root of LC. So inductance and capacitance only. For example, you can choose a telephone cable to be a distortionless line, where the inductance value should be increased by placing the lumped inductors along the line. Other than that, we also have a perfect line wherein we have R equal to G equal to 0. So smooth line is one in which the load is terminated by its own characteristic impedance, which means that there can be no reflections and therefore it behaves as a flat line or a smooth line. Then comes the definition of a lossless line. For a lossless line, R is equal to, resistance is equal to 0, which is also equal to conductance G, which is also equal to 0. So automatically the attenuation constant alpha becomes 0 and the characteristic impedance Z0 will become a real number instead of a complex number. So when I apply in the equation of gamma equal to alpha plus J beta, alpha becomes 0. I am left out with J beta, where it is J, beta is omega root of LC. So we know that the definition of Z0 is equal to root of L by C. So what are the properties of lossless line? It does not dissipate any power, it is not dispersive. Also, we define that the characteristic impedance Z0 is real. So with this analysis, we define the condition of a lossless and the distorted